from normal. Oh, good. The intro is now a secret for those who weren't able to watch live. The scale bar on the right shows that during the heat wave, we were, 20 degrees above ambient in some areas or more. And Lytton here is starred because that set the Canadian record for high temperature 3 days in a row, and then tragically burned down with the loss of 2 lives. So this was a really significant event. All right. So how hot do we think that it got on the shore? This is a picture of Lighthouse Park in West Vancouver. And if you look carefully, you can see undergraduate student Carter Burklake there in the background. He and I went out on that hottest day of the heat wave, armed with liters of water and a giant Ziploc bag of frozen grapes, which were almost not enough. We were sweating so heavily, I was worried about our safety. How hot do people think that it got on the shore that day? So we can open the second poll now for this question. All right, and while people are inputting the final few answers, I will give you some context for where these temperatures came from. 44.1 is about the temperature over a 6-hour exposure where a barnacle would have a 50-50 shot of surviving. 49.6 is the temperature Lytton got to and is the current Canadian all-time record high. 56.7 is the hottest temperature on the hottest day ever recorded on Earth, and that was in Death Valley in 1913. There are some people that are skeptical that that's a valid record. The second hottest and perfectly valid temperature is 54.0 in instrument recorded history, and that was a tie between Death Valley and Kuwait. And just remember these temperatures while I show you what the shoreline looked like if you look at it in an infrared camera. So this is a way to see the temperatures on the shore in a sense. And I want you to pay attention to the scale bar on the right, because that shows the coolest part of the image, 18.4 in this case, and the warmest part at 52.4. So even though the air temperature recorded at the Vancouver airport was somewhere in the mid 30s or maybe high 30s on this day, the rocks are getting a lot hotter than that. And we weren't trying to, cherry pick photos for the hottest spot because it was just too hot to be comfortable. We snapped as many photos as we could in a short period of time without really looking at them and then left. And the hottest one that we recorded was 56.7, which just happened to be exactly the same as the record temperature in recent Earth history as recorded by reliable instruments. So as an ecologist who studies heat waves, I had never expected to see a temperature that high on the shore in British Columbia. That's Hong Kong shorelines may see those sorts of temperatures, but Western Canada, I just really was surprised by that. Okay, so it got really hot. We have a high diversity of interesting and beautiful species that live on these shores. So here will be the final poll question for you all. Many species suffered lots of mortality, but not all species suffered extensive mortality. So which of the following did not suffer really extensive mortality? And your options are barnacles, mussels, starfish, rockweeds, which are a type of seaweed, and cockles, which are a type of clam that people harvest. All right, and we'll let that go for another 5 seconds or so as people are getting their answers in. All right. If you guessed cockles, perhaps it was because they bury in the sand, which would be a way to escape the heat. The problem that cockles have is they don't bury very deep. So a lot of cockles died. I will show you the massive mortality for barnacles, mussels, and rockweeds. The species that actually did the best were the starfish. And the reason that the starfish did better is that of these five, those are the starfish are the ones that can move over a meaningful distance. And so they're not dumb. When they sense that it might be warm, or just generally in the summer, they will retreat to shady little spots while the tide is still high, so that when the tide is low, you will find them in areas like this, sort of on these underhangs of boulders or very low on the shore. So they have their clever ways of avoiding experiencing those high temperatures. So I don't want to leave you with the impression that none of the sea stars died, because many of them, in fact, did. But it wasn't that many. You could find the occasional purple star. This is a leather star over here. And some other mobile species like crabs, like these dog whelks over here, had some mortality depending on where they are, but there were other areas where they were okay. This is what some recently dead cockles look like, but in some cases the cockles were okay. The species that really took it the hardest were the ones that are attached directly to the rock. So we've got rockweeds on the left, mussels in the middle, and barnacles on the right. All right, so I'm going to take a second to encourage you to think like a barnacle. When you are born, hatched, released from your parent, you are a free-swimming larva who enjoys several weeks of wild adventures swimming around in the ocean until you decide on a place to attach. And when you make that decision, it is irreversible. You cement your head to the rock and you build a little shell around yourself, and you spend the rest of your life in that exact spot attempting to kick food into your mouth with your feet. You can imagine that decision of where you settle is highly consequential. If you happen to settle in a place that is naturally prone to getting very hot, you could be in trouble. If you've settled on a north-facing wall, then maybe that won't get so hot. So we'll talk a little bit about that. But first, I'll show you some information from mussels. So mussels, when they die, they open up. That's why when you receive them on, in your bowl in a restaurant, they're open for you. That's just their response to being dead. So in Vancouver, mussels died. On the right, that's up in Porto Cove and Howe Sound, where it was just really, really extensive. But you don't get the true sense of it from still photos. Well, for one, you can't smell them. The smell was really, truly awful during the heat wave and for days afterwards. This is a video that I shot on Galiano Island. And I don't think the sound is going to come through, which is too bad, because it is the sound of crunching mussel shells. And normally when you walk across a mussel bed, it doesn't make very much noise because the animals are alive and the shells aren't breaking under your feet. But when they've died and those shells are now open, they're just crunching against each other. And so it was a really sort of eerie sensation being on the shore, because it smelled horrible. You can't avoid stepping on, the graves of the dead as you walk through. And this particular spot was an area about the size of a tennis court, and we estimated that 1 million mussels died in just that tiny area. But the mussel bed extends all the way down the south end of the island and makes a sort of a bathtub ring around the southern Strait of Georgia. So there's some big mortality patterns, but there's some also very specific mortality patterns. The Shore and Lighthouse Park on the left there is very complex. And so, I alluded to the fact that maybe north-facing walls would be a little bit safer than south-facing surfaces. And that's true. So what I am going to show you here are some data actually from Stanley Park, where I've plotted the percent mortality of mussels on the y-axis and the angle of incoming sunlight. So 90 degrees just means the surface, if you lay down on it and opened your eyes, you would be staring directly into the sun sort of during the hottest part of the day on June 28th. And then as you get to surfaces that are angled a little bit to the right or to the left, or back over the slope from that, you eventually get to 0, and that's the boundary between sun and shade. And all this over here is animals that were in the shade. And as you can see, if you were in the sun as a mussel in Stanley Park, you were really in trouble. If you were in the shade, you survived. But almost everything that was even a little bit in the sun experienced quite high mortality. But this sort of gives you an indication of if you were a mussel or a barnacle, that decision you made as a baby really mattered a lot. Are mussels and barnacles adapted to sort of make informed decisions when they settle? They are. Does that always save their life during a heat wave? No, it does not. All right, I'll show you some rockweed data too. Rockweed, when it is healthy, is sort of the olive green color you see around the fringes of this photo. When it is dead and no longer photosynthesizing, it turns that rusty red brown color. And we did see a fair amount of mortality with the rockweeds. That also tended to be on surfaces that face south or southwest around Vancouver. But even some slightly north-facing shores suffered. And I just happened to have an undergraduate student named Lara Calvo working in Belcara on this species, which is called fucus. And she had done some manipulations to see how important the canopy of this seaweed was in protecting things underneath of it from getting too warm or too dry. So it was very fortuitous that she had started her experiment before the heat wave. And here's a photograph from a few weeks before the heat wave with that meadow of rockweed there on the shore. And then shortly after the heat wave, you can see a lot of that meadow has died back. The remaining seaweeds there are still damaged and slowly washing away through time. So another 2 weeks after that, the shore is almost completely denuded as a result of this heat wave. And we see this sort of thing happening at many shores, just that Lara happened to have some of the most compelling photos of that sort of destruction. The reason she was studying rockweeds as a potential savior, as a sort of the wet blanket, but in a good way, is that it really does matter for the things that live underneath of it. So on the right here, you can see a whole bunch of dead and open mussels. But if you lift up the fucus and look underneath, those mussels and barnacles are still alive. They stayed many degrees cooler than the ones that were out in the sun. So that, small scale difference of having the cool seaweed blanket or not was the difference between life and death during the heat wave. All right. Okay, so how extensive were these die-offs? Here's a bit of a zoom in on that map projection of heat. Vancouver is here. And this shows that the entire Strait of Georgia was hit pretty hard. And these data are sort of an amalgamation of barnacles and mussels and clams and sand dollars and snails and other things. And this is collaborative work that I'm doing with folks based mostly in Washington. There's academics, there are tribal biologists, there are government agencies involved in this, and we're putting together a rapid response paper now. But basically anywhere that you had these higher temperatures, and I'll back up again if I can. Well, maybe I can, maybe I can't. There we go. It was hot in the Strait of Georgia. It's hot in these fjords like Rivers Inlet up here. It's hot down in Hood Canal and Puget Sound. And that's where you see extensive mortality. There is, interestingly, this sort of cool tongue of water that comes in the Strait of Juan de Fuca. And things did better where it was cooler and out on the outer coast and places like Calvert Island, where the Hackeye Institute has a research station. The wave exposed areas there did a little bit better. So there are patterns where the heat wave had more severe effects, and as a consequence, you saw a higher mortality. But not everything died. I don't want to leave you with the depressing message that everything died. Plenty of things still survived. Just sort of left to right, top to bottom, seagrasses, cute little sea anemones, oysters, mud snails, 2 species of sponges, varnish clams in my hand there, and some little limpets. So plenty of things made it through, but the touch of gray in this particular silver lining is that none of these species are native to British Columbia. They've all been introduced from warmer parts of the world, particularly southern Japan down through sort of Hong Kong, Vietnam. That region has provided a lot of the species that haven't been doing very well in British Columbia yet, but they're the survivors of big heat waves like this, and they're also able to reproduce better as waters warm up. So we are seeing more and more oysters for sure, and they're not the native species that's expanding. All right, so before I sort of get some human tie-ins, I want to briefly give you the ecological outlook for marine communities or marine ecosystems on the BC coast. How long will it take things to recover? Well, if you're a barnacle or a mussel, those things make bajillions of little babies, and those little babies drift around. So even if all of the mussels died in Lighthouse Park, which isn't true, but even if that were true, they could drift in from somewhere else and settle and recover, and that might just take a year or two. We actually see a lot of baby barnacles and mussels already. Some things, though, live for a lot longer than the sort of 2 or 3 years that barnacles and mussels live. And a lot of things like the seaweeds don't disperse for very far. So if they've been lost, it takes a longer time for them to come back. And then there's a whole bunch of species. I haven't even talked about the hundreds of species that use mussels or seaweeds as habitat. And if they've been lost because their habitat's gone, we just don't know enough about a lot of those little, worms and hermit crabs and strange little sea cucumbers and everything else to have a sense for how long it'll take that component of the ecosystem to recover. I think it is safe to say, though, that as we are experiencing more heat waves more often, and they are more severe, more likely to be severe, we are going to see shifts in the types of plants and animals that you will find if you go tide pooling on the shores around Vancouver or around Vancouver Island. All right, so what have we learned about heat waves from humble things like barnacles? Well, first of all, we can say that species that were not formerly very likely to suffer mass heat kills, and I've been working on this and I've read the literature, and every once in a while you see some mortality during hot weather, but really nothing like that heat dome that we had in June. That, in my experience, was globally unique for a temperate zone ecosystem. So things are getting hotter. We're starting to see die-offs that just would not have happened in the past. The severity of the heat wave, though, is not the same everywhere. The outer coast didn't get as hot as the more protected waters of the Strait of Georgia and Puget Sound. So where exactly you live matters quite a bit. And that's true even on very local scales. If you happen to be on a north-facing side of the boulder instead of the south side, you were safer. If you happen to be under seaweed, you were a little safer. Which speaks to this point. Sometimes you depend on other species to stay cool. Barnacles and mussels provide some refuge that's damp. The seaweed's a fantastic place to be if you want to avoid getting too hot or drying out. And we are going to see a pretty substantial reshuffling of where species live in the near future. A lot of things that are currently living in the Salish Sea, in 50 years, we may not find them in the Salish Sea, but you could probably find them in Alaska. So they may not go extinct. We just may no longer see them here. But other things are arriving to replace them. And it's not necessarily things that are dispersing in naturally from Oregon or California, because the current flows the wrong way to facilitate that. It might be things that are arriving accidentally from warmer parts of the world. All right, and we know that people are not barnacles, but these similarities are, in some cases, surprisingly direct. So where you live matters, and things are getting worse. How does that matter for humans? Here is a recent paper looking at heat waves that get hot enough to kill people. And it's not necessarily that every single person in an area that's highlighted here dies when it gets that hot. But if you are in a house that is not sufficiently cooled, or you're out working outdoors, or in a factory that's getting too warm, and I know next week's seminar speaker is going to speak to this, which should be very interesting. Historically, there were only a few places where that happened somewhat regularly. The gray areas here are just areas with high uncertainty and occasional heat waves. The RCPs are the different emission scenarios for climate models. So this is the aggressive mitigation, sort of best case end of century one. And it's getting worse in parts of South America, Africa, South Asia, Southeast Asia, and Northern Australia. We are probably more on the trajectory of one of these two emission scenarios where things are getting considerably worse. And in that bottom right business as usual scenario, a staggering 70% of the human population is going to experience at least 20 days of deadly heat waves per year. So we are really going to have to rethink infrastructure. We're really going to have to rethink, how humans are going to be migrating to move. Iceland looks pretty good, or Ushuaia down in southern Argentina, or maybe Tasmania. But there may be substantial human migration as the climate crisis deepens. All right. Well, what about local scales? I grew up in Baltimore, and here is the city of Baltimore as viewed from urban heat island effects. And so the darker the red, the hotter it gets. And you can see that the neighborhood you live in matters a lot for what sort of temperatures you might be exposed to during a heat wave. And it is not random how people are distributed across those neighborhoods. The hotter neighborhoods are disproportionately Black and disproportionately poor. And the cooler neighborhoods are disproportionately affluent and white. And it's not just Baltimore. I chose this example because it strikes home for me, being from that area. This is almost every city that was investigated in the United States. There is this disparity where the poor, more diverse neighborhoods reach higher temperatures. All right, well, there's a few reasons why that might be true. And one of them has to do with the other species that you may not realize that we are relying on to stay cool. Trees, urban trees help a ton. Areas with trees in cities can be up to 6 degrees cooler than areas without trees. And this is just a very recent study out of Adelaide showing that especially tree canopies, but even like yards with bushes can reduce temperatures. And I've been to Adelaide in the summertime, and it is so hot there now that they bring in portable air conditioning units on trailers to cool the biological sciences buildings at the university. And it gets so hot in the parking lot where those trailers are parked that they sink into the asphalt. So Adelaide is hot, but if you live in a neighborhood with trees, you're in better shape. But there's more trees in affluent neighborhoods. This is an example that was put together by the CBC this summer from Montreal. And affluent neighborhoods like Montreal have high canopy cover of trees, and other neighborhoods which are less affluent have lower canopy cover of trees. So trees are good, but they are not equally or equitably distributed amongst neighborhoods in cities. All right, we're going to see reshuffling of species and where they live. That's actually true of the urban trees that we're planting to save ourselves from some of the worst effects. These are just two headlines from Vancouver. The right one is from this summer, where trees lost their leaves during the heat wave. The left one is from 2 years ago, with people worrying about what we need to plant to future-proof the urban forest. And a lot of the species of trees that municipalities are considering are not native, but come from places like Asia or Australia or Brazil. So even our urban forest composition is changing through time, deliberately in this case, to meet the challenges of climate change. All right, so I'll wrap up with just two thoughts. One is, are heat waves our new normal? And I would say no. And our UBC colleague Simon Donner in geography, I think, answered this best by saying there is no new normal. Things are just changing constantly and rapidly enough now. There's nothing to get used to anymore. The heat wave we had this summer will become a regular thing in the future. And then, oh, remember when it only got up to 56.7 on the shore instead of 64? Who knows? In 20 years, 50 years, we shall see. But I do want to emphasize that we are not helpless in this. You saw those 3 different emission scenarios for heat waves and how different those maps looked. We control our destiny with respect to those emission scenarios. So if we tell our governments to act and we as individuals make choices that help to reduce greenhouse emissions, we can stay on a course that minimizes those types of impacts. So I think I will stop there and